Hi all.
Hello.
Okay, so we can start, right? All of you.
Sure.
So today we will go through with the Podman. Okay, anyone know what is Podman? Anyone heard about Podman? No idea. Okay, I will explain. Um, we learn Docker, right? We learn Docker. Actually, Podman is an alternative of Docker. Got it. Podman is an alternative of Docker. And why we use Podman? I mean, what are the difference between or why Podman is much better than, I mean, why we called much better than Docker. So all these things we can cover today. Okay. So before that, I will show you the life cycle or the step-by-step process of how we will using Docker and how we will build image using Docker and what are the process actually running backend, okay, within the same server. So we have a easy to mission, consider like that. This is a scenario of how Docker works, okay. So we have a easy to mission, right? So inside the easy to mission, we will install Docker to containerize application, right? So that's a requirement. So first we install Docker, then what's the next stage to containerize an application? Anyone using Docker?
Docker file.
Right. Write up the Docker file. Then using Docker, we need to build the Docker file. After build, we will get the image. Then we need to run the image. So we can see the container. So this is a step-by-step process from scratch, okay, using Docker file. So yeah, after installation of Docker only, we can do this process, right? So each process, for example, the building, we have the Docker file, okay, that's fine. For the building process, we need to run the command, right? Docker build dash t application name for image name, any name we can define, then space dot. So this is a command that we need to run for building an image. So the Docker will looking for the Docker file, okay, within the same directory. Then it will take the Docker file and build the application or build the image, okay. Then after that we will get the image. Then we need to run, right? So running, we need to run the command docker run. Then the detach mode. then the port number, then dash dash name for the application, then the container name. This is a command to run the application, right? So whenever we running, uh, okay, that's fine. For doing any activity, I mean, using Docker for building or running application, we need to run the command, right? So actually what will happen in backend, okay? Because we run these commands within the same EC2 machine, right? Yeah. This machine, there is a user there, for example, EC2 user, EC2 user. So we using the same user to run this command, right? So actually what will happen when we type any Docker command, okay? Give me a second. Okay, I will draw the backend process, okay? The pen is not working. Okay. Okay. So we install Docker in this EC2 machine, right? So Docker is running in our machine. Okay, Docker is running. Then this is a user. Okay, the user type the command Docker build. So that's the command we run. Okay. So coming to Docker, there is a middleman. Anyone know the middleman name? Okay. Whenever the user, okay, the specific EC2 user type the command and hit enter, what will happen? Okay. Whenever we install in Docker, uh, there is a daemon already installed on our machine. A daemon. What is a daemon? Daemon is nothing. We called as Docker D. Docker D. This is a daemon for the Docker actually. Okay. So daemon is actually a middleman. It's a middleman. A middleman. A middleman to take over our commands and interact with the Docker. So whenever the EC2 user type this Docker commands, this daemon is continuously running, okay, continuously running in background in our EC2 machine. So that daemon looking for the Docker commands. If any Docker command or similar like Docker commands the user run, then the daemon will taking that command and interact with the Docker. For example, building or creating image or creating volume, running application using Docker. All that's command taken by daemon. Without that daemon, the Docker can't run the process or what are the commands that we provide, it's not taking. It's a middleman. So the next problem is this middleman's need root privilege. That's another thing. But coming to this specific thing, it's there is a risk related to security. Security because that middleman need a root privilege to working doing this all this process. Whenever you so for example, whenever we installing Docker, okay. So installing Docker, after that we need to be checking that Docker commands within the same EC2 machine, we can see a error, right? The permission denied. Anyone notice that permission denied? So for that we need to for overcome this process, we need to type sudo before that command, like sudo docker build, or else we need to switch to root user. That's because of the daemon can taking that, I mean, that command instruction from this non-root user. That's a problem. Otherwise, we need to add this specific user, EC2 user or any user, okay, to the group. So whenever we installing Docker, there is a group also created. The group name is Docker. So we need to add the specific user to the group and provide that permission as well to the docker.sock, chmod 777 or some permission there. So we need to provide the permission. So the specific user can run the command without sudo. So that's a process. Okay, that's a process coming to Docker. Then, so these are the problems. Okay, the daemon and the root things, the root privilege that we provided to the daemon service. Okay, so coming to Podman, simply we can say Podman is a daemon. Docker is daemon service. Okay, there is a continuous daemon process running within our same machine where we install Docker. So coming to Podman, Podman is a daemonless service. Simply we can say there is no daemon for a Podman. Then you think in this case, okay, in Docker case, who will manage? I mean, who will manage that entire process? Coming to the Docker command and taking the Docker command and create container and everything handled by daemon. Daemon, okay, right? So here, all the things managed by daemon. Then coming to here, who will take over that process? So coming to Podman, okay, the main thing is we don't need to learn anything coming to Podman because all the commands that are similar to the Docker. For example, what are the Docker commands that we learn? For example, Docker PS, right? Docker PS for what? To see or to list the running container. Then Docker stop. Then the container name, stopping application, Docker run to running application, Docker build to build a image from a Docker file. So coming to Podman, just remove the Docker. That's all. So Podman PS, we can see the listed running listed container. Then Podman stop. So the main thing is just remove the Docker and add the Podman. So the Podman will working with the same commands. There is no difference. And only what are things that we need to learn? The additional features. Okay. So the additional features is it's a daemonless service. Then who will manage the process? For example, if you run Podman build process, okay. Also, we can using the same Docker file for the Podman. But we need to run an application, okay, or we need to build an image. So we need to write the same Docker file, and we can use the same Docker file uh, to build using Podman. Then image pulling, okay. So Docker, we can use Docker Hub to getting the image using Podman, like Podman pull Nginx, so it will pull the image from the Docker Hub. So everything seems similar. Okay. So here, okay, we install the Podman and it's a daemonless service. So who will manage that process? For example, EC2 user, right? EC2 user. This is a user. So we run the command Podman build. Okay. Build process. So coming to Docker, who will manage whenever we type hit enter Docker build, the daemon will take over and send and interact with the Docker and creating the container like that. Okay, that's managed by daemon. So here, who will manage? Here actually, the user process the same thing. Okay, so that means Here we run as a user, right? Actually, this specific user running the command, right? So the user process we can call it as a user process. That means this specific user manage the entire command and building the image. Got it. So in this case, there is no need of root privilege as well because we don't have a daemon and no root privilege. So coming to security, this is more secure compared with the Docker because this specific user can run commands, right, and build the process as well. Got it, all of you. Hello.
Yeah, got it. So like company started using Podman instead of Docker.
Hmm. Yeah, some JDs I can see Podman they mentioned
Okay.
like not fully actually because uh, they are not fully transitioned from Docker to Podman, but some case coming years they will move to Podman as well.
Okay. So the migration is easy from like Docker to Podman.
Right.
Okay.
Migration because all the commands are similar, right? So you can
Mm.
easily migrate to Podman. There is no issue. Some additional configuration that we need to do because there is no registry for the Podman. Okay, we leveraging Docker Hub as the registry for the Podman.
Okay.
Full ecosystem setup for the Docker actually. So these all the high level overview of Podman. Okay, so we can jump into the lab, right? All of you.
Sure.
Okay. So we need a server to perform everything. T2 micro is fine, but I will go with the T2 medium. So now we are updating the package manager. Okay. After that, we can directly install Podman. So now I am installing Podman. Sudo apt install Podman -by. Okay, now successfully installed Podman. So we can check the version as well. Podman -- version. See, that's the latest version 3.4.4. The Podman is successfully installed. So now we can run the Podman commands. Okay. So I don't know you remember that whenever we installing Docker, we type the Docker PS or Docker command, we will face some errors. So I will show you that. Okay. Uh, so here I will show you. I told you that there is no daemon for the Docker, right? Podman, right? So we can run directly Docker commands. So the user will take over. I mean, the user process will take over that command and process the thing. So I will try Podman PS. See, there is no permission denied issues or anything like that. For example, if you run Docker PS, okay, so I will install Docker as well to show you. Sudo apt install docker.io -y. Now I'm typing similar command, okay, Docker PS. See, permission denied while trying to connect to the Docker daemon because daemon need a root to power, right? So that's why we will face some issues to getting that information. So what? So that we need to type sudo Docker PS. So it will see. Now we can see the commands. I mean, we can see the under detail. As of now, there is no running container. That's why it's like this. Now, without that, okay, how we will I will show you this. We go through the command, right? Podman PS. See, for Podman, there is no need of anything because there is no daemon. It's daemonless. So the user will take over the process. Got it. Now we can like try to create some application, okay, using Podman. So we can directly pull images from Docker Hub. So that we need to run Podman pull image name. So it will pull from where the repository. Here are short name nginx did not solve on alias and no unqualified search string. Okay. For Podman, we need to define the corresponding registry. Okay. Because there is no native one. So we need to define that under the file. Okay. Registry dot configuration. So copy the directory sudo nano paste hit enter. So here you can see unqualified search registry. See, this is one. Okay. So this is we need to uncomment. And here you can see that registry example.com. So we need to change this to Docker Hub. Okay. For Docker Hub, we need to type docker.io. That's fine. Save and exit. Then run pull it again. See, now Podman can interact with the Docker Hub and pull the image from Docker Hub. Podman. Nginx image is actually pulled. Got it. Oh, all of you. If we have a Docker image, then we can use the Docker image as well. Okay. Any doubt? Anyone? All good, right? That's fine. We can run the image as well using the Docker run. Sorry, Podman run. Podman run -d for the detached mode, and we need to define the port number. So we can go with 8080 port of EC2 machine and the container port 80 because this is for the specific service Nginx. Okay, Nginx using default port number 80. Copy the image name, paste it here, hit enter. Podman PS. So Nginx is running fine. Now we can access the application using public API for EC2 machine using the port number 80. You see, 8080 pointing to the container port 80. That's the workflow. So can you check that is working fine or not? I will, put it on the chat. You can see the Nginx landing page.
Let me see. Yeah, welcome to Nginx.
Yeah. So anyone had it out as of now? Then I will add one more feature of Podman. Okay. So coming to Podman, we can create pod similar like Kubernetes. So for example, we need to segregate a application container. Okay. So using Podman, we can create pod. Okay. Inside the pod, we can deploy or create the container as well. So we need to do these all things manually. Okay. Coming to Kubernetes, it's all automatically managed by Kubernetes. But in this case, we can leverage the same feature of Podman to creating pod and deploy application. But this is only for the local setup only. Okay. Locally, we can set up a Kubernetes things like pod creation and container creation and everything. So for example, if we create a pod, okay? Create a pod and we run a application container within the pod. Then we can generating YAML file as well, okay? Generating YAML file for the same configuration. We can generate YAML and we can use the same YAML for the Kubernetes as well. Got it. Okay. So we will do one lab pod creation as well. For creating pod, we need to run the podman command again. Podman pod create. We need to define some name for the pod, like my pod. Then we need to define the pod number, okay? For the specific application, I will open the pod for same Nginx we can run, okay, inside the pod. So 80, 80, 80. So it will create a pod. See, now podman ps, podman pod ps, okay, to listing the pod. So this is a pod actually. Now we are going to create a container within the pod. So using the same command, podman. Only we need to define the pod name, okay. Podman run attachable mode. Name of the application. We can this is for the container name, okay. Test. And we need to define the pod name. So this specific container goes to the corresponding pod. So this is a way we define the pod name, okay. So the pod name is my pod, right? Dash dash pod, my pod. Then we need to define the image. That's all. I will go with the same Nginx image. Oh, sorry, port number is already using, okay, for the above service. Podman, yes. Podman stop. Container name or container ID, okay, to stopping a running container. Copy, paste. Need a permanent remove that container. Now I am running the command. Again, it says
That's
using.
container name test is already in use.
Okay, okay, okay. Okay, so this is fine. Now we can see when typing the Podman PS, we can see first that this is our pod actually, okay. This is a pod, and inside the pod, we can see the container is running Nginx. Okay. This is one we face here. Okay, that is this is not running actually. So we make change the name test one. So that's fine. So this is a way we uh, like creating pod and deploy the application within the pod. Got it, all of you. This is the YAML file it created. Okay. Create Podman. Save the output of this file and kubectl will create file to import it into Kubernetes. API we want kind of port. So this is a detailed YAML definition or YAML manifest that we created or that we generated for the specific port. Okay. So this is a command to perform Podman generate cube. Then we need to define that port name. Then we need to write that YAML file to any of the pod.yam. I mean, any of the YAML file. Okay. So we need to define the name for the YAML. So we can take this YAML and run it on Kubernetes. Got it, all of you. So previously we running change modification command. Coming to Docker, we need to do the same process. Okay. So we need to do that 777 chmod 777 to the specific user. So the specific user can perform, or else we need to switch to root user to interact with the daemon. So that's all the things that we face. So coming to Podman, we don't need to do anything, right? So the user can process those activities, the like Docker, Podman images like that. Got it, all of you. See, this is the problem. Coming to Docker.
So
So
most
if
of the companies use Docker, right? How can we ensure that it has a security? Since you are saying daemon is running and daemon need pseudo privileges to run
right.
commands on behalf of us to
Hmm.
interact with Docker. So how we gonna ensure that security is in place when coming to Docker?
Docker or Podman?
Docker. not Podman, since
In that
Podman
in that
might be the name.
in that case, actually, what are the things that we do? We have to define that uh, user privilege within the Docker file. Okay. So, for example, the daemon working as root user, right? So that means whenever we creating image, that everything is performed by a root user within that container image. So inside the container image, we can see, or we know that we running some minimal version of operating system like Ubuntu or any other thing.
Mhm.
Okay, I'll
Yes.
find.
Mhm.
So for that, actually, we need to define a non-root user within the
Docker
where
file.
like Docker file.
Okay.
So that's the thing. So in this case, you can see we facing that permission denied. So we need to perform that permission to the user to perform the Docker commands. Finally, we do the chmod 777 like that permission to the user. Got it. So don't need to do perform, I mean, provide a 777 user to the user as well. Only for the specific case. Okay. This is actually full privilege, right?
Full privileges, yeah.
This is for the full privilege for the user, then the group, and the others.
Others. Read, write, execute.
Sorry?
Read, write, execute 777.
Right, right. 777. So the read value is
4.
4, right? 2.
2. Execute
Execute 1.
1.
Null 0. This is the value, numeric capital representation of the permission. And these 777, 777. So the first value goes to the user. Second goes
Group.
group. And the last 3 goes to, sorry, last 7 goes to
Mhm.
others. This is the Linux, uh, I mean, permission, I mean, creating group and user, then others like that. So if we provide chmod 777, that means we provide read, write, and execute power to the user, the group, and others. That means full privilege. So whenever we provide a chmod, we need to define corresponding thing. For example, the specific only the user need to write privilege. So how will define for the first one? 4. Then go to the group and others. We can go with the null. 400 is fine. And read write to the user. We need to add that 4 plus 2, right? So it's equal to 6. So we need to define user 6 and 0, 0. So the group and users can do anything, or else that user needs to read write and the group and others only write. So 6, 2, 2. So this is the way we need to define chmod. Got it. All of you.
Yes.
All good. We can wind up, right? All of you.
Yeah. What are you going to start on Monday?
Mm. Monday, I am working in a Spring Boot application. If that everything is good, I will integrate with the Argo CD. Otherwise, I will check with the curriculum. Okay.
Mm-hmm.
And I'll ping you all before for our topics that we gonna cover in coming Monday.
Okay.
Okay. Thank you for the class, sir. Have a good night. Good morning to you. Good night to everybody else here.
Yep.
Mm.
Meantime, I will provide some task. Okay, please do it. Like some
Sure.
CACD stuff. Okay. Then we can wind up, right? All of you.
Yes.
Okay, bye. Bye then. Good night.
Bye.
Bye.